Hello, this is Ms. DB. In this video we are going to multiply special products and then we're going to factor special products. So we'll do one and then we'll undo it. So the first part we're going to do is find the square of a binomial. That means that you have a binomial, two terms, and you're multiplying it by itself. So x plus 4 squared is the same exact thing as x plus 4 times x plus 4. You don't have to use any special rule for this. You can just multiply them, write them out twice, and then FOIL. And you get x squared plus 8x plus 16. However, for some reason, people look at x plus 4 squared and think it should be x squared plus 16. They just square the first term and the last term, and they forget all about the middle term. And if you do that, you'll get the wrong answer every time if you miss the middle term. So there is a formula, a rule, that can help you remember that there's a middle term. If it's a plus b squared, then your answer will be a squared plus 2 times a times b. So in this example, a is 1 and b is 4. So in this example, when you multiply them, you get 4. A times 1 times 4 is 4. And if you multiply that by 2, you get 8. So you can see that that would give you the middle term then. And then which was 8x. And then the last term is the 4 times 4. Oh, I forgot the x here, sorry. A times 1 is, a is x. So 4x times 2. There, now it's 8x. All right, so now let's look at some more examples. This is where the common mistake is here. All right, so we have, let's look at number 2 because there's more going on there than just an x. It's a 3x and a minus 7. So the first option is just to write this twice, 3x minus 7, and it's squared, so that means 3x minus 7 times 3x minus 7. So we can just write it twice and then we can FOIL it. 3x times 3x is 9x squared because 3 times 3 is 9. Then we do the outer. 3x times negative 7 is negative 21x. And then the inner is negative 7 times 3x is also negative 21x. And then the last term times the last term is negative times negative is positive. So positive 49. And then we can combine our middle term and get 42x minus 42x plus 49. And that's our solution. Or we can use the formula. The formula says that you can take, if you have, let's see, this one is the a minus b format, because there's a minus sign in there, that will be equal to the first term squared minus 2 times the first term times the last term plus the last term squared. So in ours, a is 3x and b is 7 squared. Okay, so the first term, a, is 3x, and I have to square that. And then we'd have 2 times the first term, 3x, times the last term, 7, and then plus the last term squared. So 3x squared is 9x squared, because it's 3x. Both of those things have to be squared. So 3 squared is 9, x squared is x squared, minus 2 times 3x is minus 6x, times 7. I missed the 7 there. Let me fix that. So it's 2 times 3 times 7, so that's minus 42x. And then plus the 7 squared is plus 49. These should be equivalent. They are. So either method will work. Use whichever one you prefer. Number 7 is not written as a squared binomial, but it could be. Because 2x plus 5 and 5 plus 2x, you could use the commutative property to rewrite the second set of parentheses as 2x plus 5, which then could be written as 2x plus 5 squared. Now, if you're going to use the FOIL method, then you might as well just leave it as it is. If you're going to use the formula, then this would be your terms for the A and the B. All right, we also have this kind of special case. If you have a binomial times a binomial, and they're exactly the same, except one is a plus and one is a minus, something interesting happens to the middle term. So let's look at x plus 4 times x minus 4. First times first is x squared. The outer would be minus 4x because you have x times negative 4. The inner would be plus 4x. And then last times last would be minus 16. So when you go to combine your like terms, the middle term cancels. Negative 4x plus 4x is 0. So you're left with x squared minus 16, no middle term. And that's what will always happen. It follows that same pattern whenever you have two binomials being multiplied that are exactly the same for A and B, except one of them will have a plus and one will have a minus. And it does not matter if the first one has the minus and the second one has the plus. This will work each time. But one has to be a plus, one has to be a minus. The first term and the last term have to be exactly the same. Now you can also use FOIL to get these problems. You don't have to use a special formula. For example, in number 9, I could do FOIL. First term times first term would be 4x squared. The last term would be 2x times 1, that's plus 2x. The inner would be minus 1 times 2x, that's minus 2x. And then the last times last would be minus 1 times 1 is minus 1. So 4x squared, 0 is my middle term. So I don't need to write it. 2x minus 2x is 0. This would be my answer. Or you can use the formula, which might get you there a little bit quicker. Note that in the formula, the answer will always have a minus sign. Always. And you can practice doing these problems either with FOIL or using the formula. Be careful that when you square something like number 14, if I'm going to use the formula for this, first I make sure that I can use the formula. Okay, A is 2q cubed. Wow. And this is also 2q cubed. And B is r squared, and B is r squared. One's got a plus, one's got a minus. I can use the formula. The formula says, here's the formula, that I can just write this as a squared minus b squared. A is 2q cubed, and it's minus, always minus. And B is r squared, squared. I have to square both of them. I'm not done. This is not simplified. This is crazy looking. So when I square 2q to the third power, I have to square the 2, and I have to square the q cubed. And the other one is a little easier. This is just r squared to the second power. I wrote the same thing twice. So 2 squared is 4. Q to the third power raised to the second power. The rule is when you raise a power to a power, you multiply the exponents. So it's 4q to the 6th minus r to the 4th, because I have to multiply 2 times 2, and I get my answer for number 14.